In this video, I want to talk to you about a theorem that's helpful to prove triangles congruent. Let me remind you what it means to say that a geometrical figure is congruent with another one. It means that both of the figures basically have the same size and the same shape. Okay? So if you had two triangles and your job was to prove that those two triangles were congruent, you'd somehow have to measure the size, compare the shapes. Okay? One way is to put them on top of each other and see if the vertices line up exactly. Vertices meaning where the sides come together. Okay, and that's all well and good. Another way you could do it would be to see if all the corresponding angles and side lengths were the same. If you have so many things that are the same, you can take it to the bank that the triangles are congruent. Okay, all three corresponding angles and sides. However, it gets even better. Okay, here is what we're going to talk about. Okay, if both triangles have congruent corresponding sides, they must be congruent. Okay, let's get that clear. Now, it'll turn out that the corresponding angles will be congruent, and it'll turn out that the triangles are congruent. The point is, if you can just show this little, this part, this subset, you don't even have to mess with angles. If you can just show that the pairs of sides are congruent, you get everything else thrown in for free. Okay? Now, how can we see that this is true? Okay, let me show you something. Imagine you went to Home Depot and you bought yourself 3 sticks. You can pick the size. They don't have to be the same. So 1, 2, and 3. Now I want you to imagine putting them together and making a triangle. All right? So try to make 2 different triangles. Would you be able to? Well, let's take the first stick, and then you'd have to take one of the other sticks to connect it to the big one. So let me make a copy here. So I'll make the copy in blue, and then you take maybe the medium one. All right, and then somehow the medium one, you've got to put it at some direction and then connect the smaller stick, don't you? Now, however, because you don't have a choice about where the size of the smaller stick, you're also forced to put the angle here the same. What I'm saying is the long and medium length sticks, they have to have a certain size opening. That size opening is such, the angle between them is such that you can fit the small one. Okay? So let's say you tried to beat that system. Let's say you thought, okay, I'm going to take the bigger one, and this time I'm going to connect the small stick. Okay? Once again, you wouldn't be able to put the small stick any way you like. Okay? Because the small stick now has to be able to connect the medium stick. Okay? So you would be forced to put it something like that, and then the medium stick would go something like that. And look at what happened. Both of those triangles are, they're just rotated versions of the same triangle. Okay? If you call the bottom angles, or the angles of the triangles, let's call them 1, 2, and 3. On the other triangles, the corresponding ones are 1, 2, and 3. Okay? So it's just a reflected version of each other. So the point is that 3 sides, if 3 pairs of congruent sides is sufficient to show the triangles are congruent. Now, the name of this theorem is side, side, side. You'll see people refer to it side, side, side as the SSS Theorem. Okay? And so let me show you the way that is used to show that 2 triangles are congruent. Okay? So suppose that I had myself a equilateral triangle. Now let's make it an isosceles triangle. All right, so here's an isosceles triangle means that I have two sides that are the same. Okay? So I've got, let's say, 10 and 10, and the bottom is whatever it is. Let's say it's 8. Okay? Now, if I put a line straight down the middle, let's say that touched the median of the bottom side. Okay, so what that means, if it touches the median, that means that the bottom, if I was to put a black dot there, then that's the midpoint. Okay, so let's say A, B, C, and let's call that point M. So here's the puzzle. Okay, if one draws a line from the vertex of an from the vertex angle, it's called. If one draws a line from the vertex angle to the midpoint of the opposite side, prove that it prove that it creates two congruent triangles if the original triangle is isosceles. All right, so in short, if you're given an isosceles triangle and I draw a line to the midpoint of the opposite side from the vertex angle, can I show that I created two identical triangles? Okay, now, so that means triangle 1 and 2. How can I be sure that those are exactly the same? Okay, now, can you see that they both have a side of length 10? Okay, so we've got one pair of congruent corresponding sides, so I'll put an S, right? Our goal is to get 3 S's. Now, what does it mean to say that something is a midpoint? Doesn't that mean that it's both, this line segment has two equal sized pieces? So the bottom two, BM is equal to CM. So that means the triangle 1 and 2, they have another pair of congruent sides. So let's put another S. Okay? And would you agree that both triangles 1 and 2 share the same vertical side? They have a side of length AM, and I think you would agree that AM is equal to AM. Okay, so clearly they have a third congruent side. So they're congruent pair of congruent sides. Excuse me. So therefore, we can use SSS to prove beyond a shadow of a doubt, assuming SSS is true, which it is, the SSS theorem. Now we can prove that triangles 1 and 2 are congruent. All right, that's how that works.